I'm going to talk about cryptocurrency or wallet cryptography. And I'm going to kind of give a high-level overview, but whenever you talk about anything cryptographic, it gets deep in the weeds pretty quickly. So I'll give you that fair warning. If you've done anything with cryptocurrency already, either Ethereum or Bitcoin, this may be old news to you, but hopefully I can share some things that might help you, at least keep your digital assets safe or improve your security, and give you some tips for some things that maybe you haven't been doing already. My name is Steve Swing. I'm the Substratum CTO. Substratum is a Delaware, Ohio company. We were crowdfunded to fight internet censorship. That's our elevator pitch. Basically, we're working on software written in Rust to be able to do clandestine routing. So similar purposes as what you might use Tor or VPN for, but those have vulnerabilities or they're designed for a slightly different purpose. Our intent is for portions of the world that don't have access to the free and open internet that currently we're still able to enjoy. We want to be able to provide that technical means to solve that problem, to work around governments that want to prevent free and open internet. All right, so I've got a number of slides here that basically give examples of what we're talking about when we talk about cryptocurrency wallets. They go from the prepper version. This might be interesting to you if you think the EMP is going to take out all of our electronics, and you can etch your words on metal that's resistant, and we'll talk about what these words mean and where they come from. You can use a paper wallet of form where you can generate a QR code that you can share, and you can keep your private key private, and use a printed paper wallet. You can even have a little USB dongle device that prints that key for you, the address that you can share. You keep your private key. Every time this mycelium device is inserted into a compatible printer, it'll generate a new address that you can use. Perhaps you've heard of some other hardware wallets like the Ledger line of products. This is a Ledger Nano S. It's a USB device you plug in. You use little buttons on the 1 or 2 line display to enter your PIN code or passphrases and go into modes that are specific to each cryptocurrency denomination that you're trying to work with, whether it's Ethereum or Bitcoin or some of the others. A little more advanced version that they have, a different product. Same kind of a thing, but a touchscreen display where you can select the coin type that you want to work with and interact with your wallet. It basically maintains your private keys for you. Trezor is another example of different orientation of the 2-button style kind of a thing with more lines to display. Keep Key, I think the interface or the screen on this is touch sensitive so that you can navigate and control it. All these kind of have a common, physical aspect, hardware wallet wise. Then we get into some software wallets. One of the earliest ones is Bitcoin Square, or they renamed themselves to BISC. Uses a cute cross-platform development type of thing, and Bitcoin, there are a number of other versions of this type of wallet that probably came from, one of the several originating projects that provide wallets. Electrum is another example. And then we get into mobile wallets. I know you can't read this at all, but the point of this is there are even more now. I think when I took the screenshot, there were 170 when I took the screenshot. Last night I looked, there were like 181. So there are a lot of options. And even some for iOS, surprisingly enough. All right, what are we talking about? So the cryptocurrency wallet doesn't actually store your coins or tokens in that little device. Certainly the little metal thing that you etch your words into, your mnemonic phrase, can't hold the Bitcoin or the cryptocurrency. Cryptocurrency is stored in the transactions on the blockchain. So it's either unspent transaction outputs that Bitcoin uses, or in the case of like an ERC20 compatible token like Ethereum, the smart contract state holds the current balance for a wallet address. So essentially these wallets are a mechanism to just keep track of our private keys, keeping our private keys private and giving us the public key so that you can verify that you're the owner of the private key, or the private key. Everybody has the public key. And so in order to not lose your cryptocurrency, you have to keep your private keys private and secret. So another analogy is you can sort of think of your cryptocurrency wallet more like a debit card. So your debit card doesn't hold any money in that little piece of plastic. The newer ones have the chip that basically authorize you as the holder to be able to withdraw funds from your banking account using that card, and ideally the PIN, so you sort of prove that you have the private key. And with all types of wallets, we have different sorts of downsides or negatives. No one solution is perfect. They all have things that you need to be aware of. For example, with paper, a fire can easily burn up a lot of Bitcoin in not much time at all. Or flood, or your printer ink could fade over time. And if you memorize your mnemonic phrase and keep it in your brain, all it takes is one good conk on the head and you've maybe forgotten your phrase. Software, we need to be diligent in our day jobs for keeping data safe, but when we're talking about cryptocurrency, we also have to be aware of unauthorized access, and it's a financial loss, maybe more immediate than what data seems. When you lose data, it's still a financial loss, but it's hard to quantify a lot of times. And then, with hardware wallets, if your mnemonic phrase is leaked or you forget it, then it's subject to loss as well. Hello. Sorry about that. All right, so what are we talking about? Cryptocurrency wallets use asymmetric cryptography, right? You've got a public-private key pair, and they go together. You need to use a private key to decrypt data that's been encrypted with the public key. You need to confirm that you verify the signature with the public key that's been signed with the private key. So those are the kinds of things that we're talking about when we use public and private keys. Very similar to the SSH keys you might use for authentication, or similar to website identity for certificates. There's that signature type of cryptography involved as well. And for communication, and you'll see in some of the formulas here, there's a hash-based message authentication code that can be used to verify that a message hasn't been tampered with. And then all involved with all of these are the Sha Variants for secure hashing algorithm. So, and you may see Sha 1, 2, and 3, but know that also what they're talking about is most likely Sha 1 is 128, I think, right? But Sha 2 and 256, or Sha 3 384, and Sha 512 being the most common ones used for cryptocurrency. So, much to my surprise when I was researching this, that there are actually standards around Bitcoin and Bitcoin technologies that go into these are examples of the standards that go into defining cryptocurrency wallets and what we're using. So we're going to look at like 4 of these. There are others that influence or control how a particular coin might work through the standard that they've adopted. But these are on GitHub, and you can review them and look at their reference implementations. Often, a couple of them provide test cases, so that if you're implementing your own software stack that implements a standard, you can base your test case on those standards to verify that your implementation matches what other languages are developed. Some of these aren't even finalized. Some are just proposed, but yet they're kind of in use as de facto standards. So, yeah. So the first one, looking at BIP 32, which is the definition of hierarchical deterministic wallets. BIP 32 defines the path of derivation functions that's used to generate child keys from a master key node. So the whole thing starts here as an input of entropy. And this is your master seed that is hashed, and you end up with a master node of a key pair. And then at each path level, which is basically a recursive descent tree, where you've got the first index, you can use any digit at each level and pass it through this child key derivation function, and you end up with a new key pair that can then be fed into the next level. And at each level, it adds a different value, and you generate new child keys at each level until you're ready to stop, till it takes too long to compute them. BIP 39 is a mechanism by which most people are familiar with. If they're using a hardware wallet, they're familiar with the initialization seed words that a hardware wallet presents when it's first initialized. So you get a number of words. It depends on the amount of entropy that you want to use to set up your wallet. The entropy is encoded in multiples of 32 bits, and so it needs to be a multiple of 32, and it can be from 128 to 256 currently. At each level, that entropy is divided by 32, and then you end up with an amount of checksum that's necessary to verify that the mnemonic sentence actually is correct. So there's a built-in checksum. And the checksum is based on 248 words that are in a word index. Basically, a decimal value is generated from 11 bits, and the 11 bits, the 11-bit value in decimal is the index in the word list. I have an example of this that kind of walks it through more clearly, I hope, where I try to explain it. So let's say our mnemonic phrase is 24 words. The word lists are defined in the BIP 39 standard. So they're a fixed 248 list of words, index 0 to 247, because that's what will fit in 11 bits. And there are different word lists for different languages. And they're not just translations of the words. They're completely different words. They can be. I think they are. I don't read most of the languages, so I don't know. So you've got 256 bits of entropy. It looks like that in bits. plus the 8 bits checksum, and that's a total of 264 bits. So if you were to look at it in nibbles, which is kind of close to 11, you've got 12 bits in 22 rows, but what we need is 24 words. So we're going to steal 1 bit from each row and add it to the next row, etc. Not quite that scrambled, but you end up with 24 rows of 11 bits, still 264 bits total. So then those binary bits are converted to decimal index, and you end up with the word. So the important thing to capture, if you're going to capture anything, especially if you're going to etch it onto metal, where you might not have access to a computer because of the EMP, the thing that matters is the index. The word is just a handy mnemonic, get it? That helps us remember what that index word was. So BIP 44. This is a refinement of the BIP 32 standard that defines the segmentation or the paths for defining the child keys and the derivations. 44 actually puts descriptions on each of the levels. So they say that from your master key, the first path segment is a purpose, and then a coin type or an account, and then a change, which Bitcoin uses a change address. And then you end up with an individual address index. So you note this little prime here, that was intentional. It's really 44 prime is the purpose. And what that indicates is it's a hardened derivation path. If you read the BIP 32 standard using the key derivation function, if you use values less than 2 billion in that key derivation when you do the descent, some of those combinations are vulnerable to leakage. If someone gets the private key, they can derive all the remaining keys in that tree, or depends on the value. Then in this case, BIP 44 defines that the second segment is the coin type. So this is where you see different coin values. 60 prime happens to be for Ethereum. I know Bitcoin has used 44, but also 49 prime I've seen. And then from an account. So an account is just what I choose to use. It's a hardened address, but typically 0 is used most commonly. But starting from, actually it would be this higher order bit is set. So it's going to be, when it's 0 prime, it's actually this number, an 8 followed by 7 zeros. And those hardened values actually go from 0, 8 followed by 7 zeros to 8 Fs, if you're looking at them in hexadecimal. Very, very large number. Now, where you see these things most common, if you're familiar with My Ether Wallet is a website. It's basically an HTML page that encodes a number of these standards so that you can use this HTML page to basically access your wallet and send Ethereum transactions on the Ethereum network. And here's, when you unlock your wallet, here's what the next screen you're presented with. And something should look sort of familiar now, hopefully. For Ethereum, the purpose type is 44 because it's the BIP 44 standard. And then 60 indicates Ethereum. And since we're dealing with My Ether Wallet, that's what this indicates. You will see some of the other coin types listed. And so if you wish to hide your money, sort of, you can actually choose, if you had a Ledger hardware wallet, you can actually use this particular brand, Trezor, and basically it doesn't matter. There's different software implementations that utilize the different derivation path. So 44 is the purpose, this is the coin type, this is the account, and then if you're looking at the bottom of the page, it's showing you all the indexes. So like, for example, when you pull it up, it won't be all zeros. It'll be for your particular mnemonic phrase or your key store that you've opened or unlocked using My Ether Wallet. MetaMask is another option for using a browser-based extension. I don't have a lot of experience with it. So what we're talking about with wallet safety, really everything you've learned about internet safety applies. Okay, we're talking about good password hygiene, making sure that you keep things private that are supposed to be private, keeping things secret that are supposed to be secret, like your private keys and your mnemonic phrase. Make sure you use unique passwords. Make sure that you enable second factor authentication on accounts that support it. So any exchanges you're using, make sure you use those and turn on all of those. Try not to use SMS as your second factor, where you get a message on your cell phone. That has been shown to be vulnerable to exploits. And in fact, in the news this past summer, criminals were apprehended for playing the social card and doing the SIM swap thing. You've heard about that in Florida. Somebody lost billions of dollars in cryptocurrency because AT&T allowed someone to basically hijack his SIM, and they got a hold of the second factor authentication codes and was able to get into his accounts and steal his cryptocurrency. So if you can, use Google Authenticator and other second factor. Google just recently made for sale hardware devices that are little Bluetooth dongles that are your second factor token, and using a hardware key, you can use that as a second factor. So just be aware that very often, even with all the technology, the social aspect is very often where most people are vulnerable. So don't fall prey to phishing schemes or scams. The other thing we can do is keep our software up to date. So make sure that you keep your OS patched with all the security vulnerabilities. Use an evergreen browser so that every time you launch it, you get the latest version. Make sure all your security patches are applied, and make sure that any of the extensions you have in your browser don't have vulnerabilities. Those are sometimes not as obvious to check. And then if you let anyone else use your computer where you do any cryptocurrency transactions, that's an additional risk that you have to be aware of. So for some other obvious things, keep your mnemonic recovery phrase secret. Write it down by hand. Whatever you do, don't photograph it, because when it's on your phone, guess what? It gets backed up to the cloud, very often like Google Photos. And if you forget and you have your Google Photos public, you've just leaked your mnemonic phrase. So store it carefully. You do want to write it down and store it in a secure fireproof place, or etch it onto metal like you've seen. And take the other precautions. Use a good printer with good ink, or a good pen with good ink. You can laminate it. Yeah, don't forget to test it also. So before you put any cryptocurrency on your hardware wallet, make sure that you can basically reset it from scratch and do it again using the recovery phrase you wrote down. Maybe you didn't write down the word correctly, or maybe you can't read your handwriting. Make sure you test the recovery phrase before you actually put any money in those addresses. And then if you're really concerned or you're in a high-risk area networking-wise, your apartment complex, you have shared Wi-Fi, you don't really have the ability to, or in your dorm, maybe you want to use air-gapped hardware. You can disconnect from Wi-Fi, use my Ether wallet locally, and I have a couple examples. I'll show you how to do that. You can create and sign your transactions offline, and then reconnect, and then take that signed message and send it through the Ethereum network or Bitcoin. You can use USB and brand new flash memory that's never touched a computer that's been connected to the internet. You can also use the skills you may have learned at work to do Docker images and that sort of thing, or virtual machines, to sort of help create that air-gapped environment where you can do transactions securely and safely. If you use Electron at work, I got an example to show you. Or you can just use local standalone HTML pages. So let's look at some of these examples for using Docker with my Ether wallet. So what I've done here is set up it's already logging. I've got a Docker image that I generated, and I called it my Ether wallet offline, mu offline. I basically took a simple Docker file and put an HTML page in it that is the my Ether wallet source. So if I went to that my Ether wallet page on the internet, I would see this same page, but this is the one that's running on my local. You can generate your own certificate. You could use like let'sencrypt.org and configure that so that you get a valid certificate for yourself and set it up so that it auto-renews. Don't use my Ether wallet if you see this red not secure. It's probably a phishing site. And if you go here for the first time and you see all the pop-ups, it's a good idea to at least read through them once. You can easily clear them just by clicking anywhere. But every time it pops up, you get all this disclaimer just to scare you away from, we know this click-through stuff is annoying, we're sorry. So I'm actually connected to my local host, which if you saw the logs that we're printing, and I can view my wallet info. If I wanted to take that mnemonic phrase that I had earlier, let me fire up a fake Ethereum miner called Ganache. You can use this to test smart contracts for deployment. I can take the mnemonic that's here and I can paste it into my Ether wallet. The password is optional. I just recently learned that if you put a password in here, I know that Ledger and I think Trezor hardware wallets support entering this passphrase. It does change your wallet addresses. It's a completely different set of addresses because the master key that gets generated is different. When you do this on the Ledger wallet, it says, please wait while we reconfigure your device. It is temporary so that whenever you allow the wallet to go to sleep and you have to re-enter your PIN to open it, it will be reset back to without a passphrase. So you could use that side of the wallet for day-to-day, simple, small amounts of transactions. But if you want to do something more secure, you can put in a password here and you will have to enter that temporary password to sort of unlock those hidden addresses from your hardware wallet. But this is exactly the same. So I can choose any of these, and I see the different addresses. I happen to be connected to the Robston Ethereum network, which is one of the test nets. So this, anything that would appear here wouldn't be real Ethereum. It'd be the fake stuff. But you can test with this. So you can use this same address for Robston or mainnet Ethereum. There are Ethereum faucets that if you want to create a smart contract and deploy it to Robston, you can play around with how that would work and create your own smart contract using Solidity and test it with Ganache. So you'll note that if you can remember, I usually look at maybe the first 3 or 4 or 5 characters. Usually that's different enough. If I look at my Ganache instance, that's the same number. So I've confirmed that by choosing the same BIP32 path, 44 prime, 60 prime, 0 prime, 0, and account index of this one is 0, that this happens to match that particular wallet. And the rest should match as well, because it starts at index 0 and increases by 1. Now if I were to choose a ledger as if I had a ledger hardware wallet, what's at address 0 is not the same. It's basically the parent of this derivation, where this has 1 extra 0. It's gone through the key derivation function 1 extra level and passed 0 in as the value or the seed. So I can use this to create offline transactions using this page. Access your wallet, generates the signed transaction. Or if I just want to send something immediately, I'm not too concerned about security, I can unlock the wallet. And choose which address to send from. There isn't anything in there, but put in the destination address and the amount I want to send. So let's look at the other example of using Electron. Electron's interesting because, well, there's a lot of projects that are written in Electron that you may have heard of. VS Code, Atom, I think the Ledger Live software that you can use with your Ledger hardware wallet is an Electron-based application. There are just a surprising number of applications that are based on Electron, which is originally, I think, a GitHub project that uses Chromium inside of it. So there's basically a version of Chrome inside the Electron project, and it uses Node.js type modules to basically create an application suitable for the desktop, but it's very portable because it's based on Chrome. So everywhere that Chrome and Node.js run, Electron is able to run. So similar to this, I took an Electron basic starter application, and I took the BIP39 page from the GitHub account of Ian Coleman. He has a BIP39 repo. There's an offline version. You can copy that into your Electron project and run it, and the result of that is a mnemonic code converter. So I can use my same BIP39 mnemonic, confirm that, okay, this is promising, it has a seed. I can look at the entropy details. Sometimes this doesn't display correctly. It thinks I have blank entropy. 24 words. No, sometimes it has displayed. I really have to put the entropy up here. So that long hexadecimal number that I said was the entropy that went down into rows of nibbles, I put that value here and it will repeat some of the information that you saw earlier. But it does give me my word indexes, which is the important part. So if I hide the entropy details, we can look at the addresses. And again, it's important that I choose the correct coin type. So if I want to look at those same Ethereum addresses, and then I have to choose my derivation path. So BIP32 is sort of a free form. I can put in kind of whatever I want. BIP44 kind of adheres to what I've selected before. It's the purpose type is 44, the coin type is 60 because I chose Ethereum from above, and then it also has the ganache extra level versus what like the ledger does. But I can find my same CD70B address here, along with the public key, and then even the private key. And if I click on it, it gives me the QR code if I can scan it. But just beware that the camera it gives you a little warning. Caution, the scanner may keep the history of what you've scanned. So again, there's 4 levels. If I want to look at Bitcoin, what Bitcoin addresses look like, I can even choose like a Bitcoin testnet, for example. And the testnet is slightly different. The testnet, there are node modules that let you validate Bitcoin addresses. So it can kind of tell you, sorry, you've pasted me an address for testnet, and really what I need is the mainnet address, because they happen to start with a limited number of prefixes. So when you see these numbers, hopefully you have a better understanding now of what those exactly mean. Don't worry if you can't do the math. I still can't do the math either, but at least I kind of have an understanding of what they mean. So by running this Electron app locally, I don't have to worry about extensions that I might have that are malicious, because it's in its own special copy of Electron, and I can rebuild it and make sure that I can run it locally when I generate my initial mnemonic phrase. And then if you speak another language, maybe you've got an additional level of security, because you can use something that most people where you live doesn't understand. So the word phrases are based on these other values. And it knows what word they are. It's not the same meaning in the word, but the word index matches that word list. All right, so a couple things to wrap up. It's okay to diversify. You can use multiple hardware wallets, but you don't even have to buy multiple hardware wallets. Either using the passphrase or using different initializations, you can take advantage of having different wallet addresses to keep your cryptocurrency diversified so that it's not all in one place. Or you can maintain assets on different wallet types. You don't need to necessarily have the same mnemonic phrase in everywhere that you use. You can have multiple mnemonic phrases. And then one thing to keep in mind as you maintain your cryptocurrency assets over years and years, consider your survivor access for your heirs. Be sure to leave instructions on how to access, especially if you have significant wealth in cryptocurrency. You want to be able to pass that on to those who follow you. Leave instructions either in a safe deposit box or an estate attorney or someone else that's trusted. And then just be sure to keep the information updated as you change things. As you stop using one particular wallet, or you have a passphrase that gets leaked, or you're not sure if it's leaked, and so you want to use something else, update the information so that people can find what you have. Any questions? These are the contact info. I'm on Twitter at @swing. There's my GitHub account, although I don't have these particular projects there. I may push them there soon. Today is the Ohio Linux Fest. You've just been witness to that. If you want to find more about Substratum and what we do, there's our website and our Twitter account and YouTube channel. Anybody have any questions? Go ahead.
I have a couple of questions related to theft. So my question about, or the first part of my question, the incident down in Florida where someone went through the trouble to spoof a SIM card just to get that 2FA. Was that person targeted because of their profile in the community, or did they owe the mafia a ton of money, or what triggers that kind of reaction out of somebody to go through all that trouble?
So the question is, with the theft in Florida and the SIM card swap, was that person targeted? I don't know, is the short answer. I mean, if that person was like high profile and bragging about how much cryptocurrency they made or some deal, then they may have sort of made themselves a target, or information leaked. I don't know about that specific case. That's something interesting to search and figure out. So I guess the moral of that story is you don't have to make yourself a target if you don't want to.
Okay. And my follow-on question to that, because one concept of security is, okay, you know how the lock is made, you know what's on the inside, but you still can't open the lock without the key, right? How much of that applies to the hardware wallets, and more to the point, how many layers of tinfoil do I need on my hat, in order to pick a good hardware wallet?
When it comes to security, it's always at odds with convenience. So I think you have to decide with the amount of convenience you want versus the amount of security you want, and it's completely up to you. It is sort of reassuring that if I generate if you have a choice, it's good to use more entropy. And so 24 words gives you the most entropy that BIP 39 will support. So if I generate entropy and show the details, it does say that this amount of entropy takes centuries to crack in terms of our current compute power. And I still think that quantum computing is probably a ways off from actually being able to crack 256 bits of entropy. We may eventually get there, and people are working on quantum resistant algorithms. So, does that answer your question?
Yes, pretty much, because in some advertising or some testing, people were taking the hardware keys apart and saying, "Oh well, someone with an electron microscope could blah 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 blah." And it's if you're worried about that, I think you have larger, actual, real world problems to deal with rather than the particular manufacturing method of your hardware key. You know what I mean? It's
Right.
That's close to a 3-letter government agency territory, or Russian mafia, Chinese triad territory.
Yeah, I mean, I will say when it comes to purchasing hardware wallets, make sure you buy them from, a reputable source. Don't just grab any old one off eBay. That's, and put a lot on it. Really, you don't necessarily need a hardware wallet when you've got software tools like this BIP39 mnemonic code converter, or things that you can basically do what the hardware wallet does. The hardware wallet just gives you sort of a convenience. Although, if you do use that passphrase feature to enter temporary passwords, it's kind of a pain because you basically have to re-enter the password every time you enter the PIN to unlock it if you go into that mode. So, yeah, any other questions? Does this convince anyone that cryptocurrency is too hard? There's no way I want to do this at all that's not been into it? Well, that's good. Jed, you had a question?
I was going to say another advantage of the hardware wallet is the private key never leaves the device.
Correct.
So it's something that is signed by that private key, but not the key itself. So there's some additional security there.
Right, so the hardware wallet, the point Jed's making is that the key never leaves the device, your private key. So the data that for the transaction is sent into the hardware wallet, and the hardware wallet produces a signed version of that transaction. And so the software that reads it out is able to be sent securely without leaking the private key at all. So, any other questions? Well, thank you so much for coming. Hope you learned something.